Hello, everyone. It's 3 p.m., so I guess it's time to start. So the topic I prepared for you today is about microservices. And you might be thinking, oh yeah, here comes another one. We've been talking about this for so many years already. But I kind of specifically avoided speaking about the subject for many years. But now, after working with so many microservice-based projects, I started noticing some patterns to emerge. Patterns that many teams keep repeating, and those are bad patterns. And I think I have 6 of them for you to discover. I do some blogging over at forcomprehension.com. I usually act nowadays as an independent consultant and trainer, but I'm also a fresh Warsaw Java user group leader. If you want to find me on Twitter, X, that's also pretty easy. So microservices have been there for a long time. And I remember it was, I think, around 2013 or 2014 when people were specifically seeking companies that were going from monoliths to microservices. And those companies were getting quite a lot of hires. It was quite easy to attract people there because it was hot and interesting and quite a novelty. So suddenly going from your old school Java enterprise monolith to microservice-based project was fresh and interesting. But now it's pretty common. So as you can see, if you browse job ads, actually turns out most services are based on microservices, which is pretty interesting because that pattern is pretty powerful, but I don't think it's also that widely applicable. And if you have a look at, everyone's doing microservices. But what's more, it turns out that quite many of those companies in those systems are doing microservices without really benefiting from them. So they spend extra time, they spend extra money, they hire more people to work on the extra infrastructure that they don't really benefit from because of some things they are doing. So my goal for today is to bring you up to speed with a couple of those ideas. So next time when you face a microservice-based project, you don't repeat the same story all over again. So unfortunately, it turns out that most services, most projects I've seen, they indeed started with monoliths, but they ended up with bad structure. They started as bad structured monoliths. So there was some lack of discipline that led to their system looking like a big ball of mud. However, suddenly migrating to microservices won't make your system better. Well, naturally, going to microservices enforces some form of modularization. You need to do that if you want to split the system into smaller parts. So there is some benefit from that. But if you don't do this properly, you end up with a couple of smaller problems. But the problem is, if you slice Poo into smaller parts, the surface area gets bigger. Well, you can always slap a service mesh on top of that, but it's always problematic. So this guy invented null references. So yes, actually, around over 50 years ago, someone actually needed to do that. Someone actually went ahead and invented a null reference. And later on, in a couple of his articles, he brought up that it was his biggest mistake. And he called it his billion-dollar mistake. So apparently, if we went to the future with the world of no nulls, that's how that could look like. So let me start the presentation with a pretty bold statement that another billion-dollar mistake was microservices. But don't get me wrong, not microservices, but microservices. That micro in the name caused surprisingly quite a lot of confusion because we've had a kind of similar pattern in the past. We've called it service-oriented architecture, but for some reason we assumed it's about event buses, serial buses, and XMLs and SOAP. But then microservices emerged. And those are no longer services, those are microservices. So that's where the first problem arises, that's of size obsession. What does it, so we are building microservices now, so what makes a service different from a microservice? How small is actually micro, how small is good enough? And there are really various metrics that you can use, because those can be n lines of code. So some people will tell you that 20,000 lines is too much for a microservice. Someone will tell you 8,000 lines is too much for a microservice. And as you can see, this is, as we understand, that judging the size of a service based on the number of lines is probably not the best metric out there. What else can you use? How many classes do you have? How many files do you have? They all seem to be suboptimal, right? How many megabytes do your artifacts have? Actually, a pretty good one, that probably the best of those suboptimal ones that you could come up with, is how much time does it take for you to rewrite the service? Some people will tell you 1 week, some will tell you 2 weeks, but the idea, that sounds as close as possible to as something that gives you actual value. But before I try to answer that, let's recall the main value of microservices. Because the microservices is not about coming up with so many microservices. And this seems to be a common pattern. So not a long time ago, I joined a team, and I was asked to do an audit of their microservice architecture. So I started speaking to the team. And they said they already had 60 microservices, and they were quite proud of that. Well, at that point in time, I didn't really know if that's, if that's too much or that's not enough. They said 60, and then they told me, but we are planning to adding at least 20 more. Okay, and I'm like, okay, that's a red flag, because probably people don't really yet know what they want to build, but they still want to make it very, very granular. So that's an indication that something might be going wrong. However, so I asked them, okay, wait, don't remind me, how many people are on the team? And they said 6, and I'm, okay, so you have 6 people, you made 60 microservices, 10 services per person, and you are planning to add 20 more. And they were like, yes, like quite happily. Like it was a big achievement for 6 people to make 60 services. Well, I must admit it was pretty impressive to see them managing that, because they managed that somehow, and the overhead was pretty big. And then, okay, so one more, okay, maybe there is something else that justifies that. So, guys, please remind me, how many customers do you have? And they say 1, and I'm like, but 1,000, 1 million, what? No, 1, like literally 1. That was a very early stage project that started as microservices. So they built up so many of them and then planned to dig more. So there was not really a traffic, no really any practical pain to solve by using microservices, but still someone jumped onto the cargo cult and developed 60 of them. The original idea of microservices was to enable scalability through independence and modularity. And when I say scalability, it's not always just about being able to support more HTTP requests coming in at the same time. It's more about team alignment and org scalability. Because if you throw 6 people at a monolith code base, they can if you for 1 person, that's super easy. That person does everything. They do their own code reviews. They merge. Anyway, there is zero conflict, 0 traction. If you start adding more people, you spend some time on synchronization reviews and so on. But as you keep adding people, at some point it starts getting slower and slower, because everyone's stepping on each other's toes. There are constant conflicts during code reviews. Suddenly there are those races who is going to merge first, and others suddenly need to update. And if those are big changes, this can be pretty annoying. So the original idea was to take this monolithic code base where everything is tightly coupled together with low cohesion. Tight coupling means that everything is tightly connected, and low cohesion means that things that not really belong to each other. They are spread apart. So the original idea was to take this, modularize this. So create a rigid structure where all related stuff is put together. And this such a module, or service, you can say, communicates well over publicly and stable public API with another ones. And this gives you a great opportunity for scalability, because when you are working inside that one particular module, suddenly you don't need to sync with 60 people. Because if you designate one team, let's say 10, max 10 people, 60 people, 2 people that own this particular module, they will be a bit more efficient than if they were part of the bigger group, like 60 people trying to work on one single monolithic application. And the only part that couples them to other teams is the contract, those arrows that are between those modules. And that's the original idea. So, of course, there can be systems that have huge scalability demands that need to scale independently, auto-scale, because there's so many requests and the data is, the volume is variable during the day. Okay, then you might need to pull those services out, make them cloud native, auto-scale, and so on. But the main idea was to enable scalability of orgs, because now instead of one big team, you have smaller teams which work on their own parts and they don't step on each other's toes, or at least we minimize that part. And the cool part is that you can have some of those benefits, but some of those benefits even without microservices, because you can introduce modularity even at this middle level. Because we are very good at modularity at low level, because they teach us at universities that we go with fields. Fields should be private, methods should be public. We just learned microservices for a couple of years, and we know that we modularize at a very high level, and we split functionality into different services. But there's this middle part that we can tackle as well. Obviously, that won't tackle all the issues, or this won't give you all the benefits of microservices, but at least you get this independence of working in every module without touching things that you don't want to care about. If your monolith looks like this, it's quite likely that you're probably touching some implementation details. So imagine the red ones are for movie rental, and the yellow ones are for account management. It's quite likely that at some point, someone, that yellow dot touches some implementation details of your database that does rentals, or access some utility methods that they shouldn't be accessing, or some domain classes that should remain internal to the module. That becomes incredibly painful to refactor, because suddenly you need to do a surgery and move all those small things around, all those dots, those arrows around. That's hard to maintain. But if you introduce modularity even at this level, you can solve this issue. Naturally, it will be still hard to work on one big code base with multiple teams, but you get some benefits. But the good part is that's not a demanding investment. You don't need to build complex infrastructure to support modular monolith. That's something you can do pretty easily. So when you are just starting out, it's probably a good idea to start with monolith first, and then slowly evolve into microservices, ideally with this step in the middle, involving bridging a modular monolith. However, if you are starting out from microservices, your project that has no customers, no traffic, that's probably a sign of over-engineering. If you want to do a bit of over-engineering, probably you could start with modular monolith first and be better off with that. The problem is, with the size of microservices, the problem is that the smaller the service, the more you maximize the benefits and downsides of the architecture. The problem is that if you go lower, if you make them smaller and smaller, the downsides don't grow linearly. They grow exponentially, well, more or less. So there is a problem, because the more you produce them, you start dealing with more problems with infrastructure, deployment, probably AWS costs, because suddenly your every function becomes, in the absurd scenario, every function becomes separately deployable. And you might end up with something like that. So that's the pretty much graph of dependencies between services of Netflix. as you can see, that's quite a lot of them. It might sound like it's a terrible idea, but there's one important context. They didn't start with this architecture. They didn't produce those thousands of services when they were just starting out. That's something that evolved into along the way when they were building their team of 2,000 engineers. Well, now probably a bit less. But that's something they ended up with converging to after many years. They didn't start with that. So generally so when you ask me about what's the max size of a microservice, that's usually a bad question. But there is very good indication, but I can tell you when it's a good moment to start splitting them. So instead of thinking, okay, that's the right size of a microservice, you should be asking yourself, do I experience enough pain that justifies the split? So let's say you're working on a monolithic code base. There is 30 people working. And suddenly it's becoming really hard to talk to other team because they are working on this big feature that needs to be shipped. They tell you, okay, don't touch anything because we've already done our QA and we can't really risk doing any regression. Stop your work. If you need to start synchronizing, if your pull requests merging becomes problematic because of the constant merge conflicts, and so on, at some point, this is real pain. If you want to try to address that, you might introduce a slice. So you don't get me wrong, you don't take your monolith suddenly and you slice it into 50 services. Quite likely you would slice it in half, or in 3/2, whatever. The point is that you start experiencing pain and you start tackling it. And what it makes sense is to do it evolutionary, step by step. So we split it, well, it's hard to say split in half, but we take away the part that's problematic that feels like deserves its own release cycle. We take it apart. Congrats, now we have 2 systems, and now we get some benefits from that, but congrats, now it's a distributed system, and you're prone to the fallacies of distributed computing. So generally, try to stick as long as possible to a monolith until you feel something is wrong. Then, when you start splitting one by one, you are maximizing the benefits and minimizing the downsides that comes up that is a result of over-engineering. So what I found a pragmatic default. So if you look at the whole scope of the market and all the systems at different stages of development, Netflix is on the one side, is on the edge, which is a very mature product. On the other side, there's many projects that are 1, 2, 3 years old. So what I ended up seeing as a healthy default, a healthy state, is something as they call the majestic, that's what DHH called the majestic monolith, which is a big modularized monolith somewhere in the center, but with a size of some splits. So there will be one big monolith in the center, which is in the process of getting trimmed. However, around it you can see a couple of outpost apps that were actually pulled out of it because of very good reasons. Those were either problems, with the giving some parts independent release cycle, or perhaps scalability, driven by scalability, because maybe this small particular part needs to actually be auto-scalable because of some reasons. And that ended up working really well, where you would actually don't experience so many downsides of microservices. Another pattern I'd like to talk to you about is the old habits die hard, and it's the second biggest problem, and unfortunately it's not for many of you to solve by yourself. So you decided to go into microservices. That ideally requires alignment of the whole organization. So if your management is not actually aligned on that, it might end up pretty bad. So what I've seen happening is that you have microservices, but you still try to work with that as if it was a monolithic project. So how does it look like? Well, you have single version for all the services. So when the release time comes, you tag every services with the same tag, and then you probably do some QA, and then you release it all to production. Okay, and this can work, but if you still want to work with your system this way, you'll be probably better staying with a monolith, having a single tag and not play around synchronizing deployment of 50 services at the same time. That defeats the purpose. You've done your split. You've invested into infrastructure so that you can have independent lifecycle. But now you still act like it's just a single code base. The same applies to all or nothing deployments. Same team I told you about earlier. I joined them and they did the same. So it turned out that they would release all the microservices at the same time once every couple of months, and they would deploy everything at the same time. And the question was, why do you do that? So you've invested all that money from scratch into this architecture, and you don't want to benefit from the things that it gives you. And the answer was, that we can actually deploy all the services separately, and we can release them separately, but it's safer not to. So they would just deploy all the services at once every some time. Another thing is, another anti-pattern I've seen, that you create product teams that consists of code monkeys that just develop their code. However, there is somewhere on the side a DevOps team. Well, it's not really DevOps, but you know what I mean. There's an operations team that's actually gatekeeping and safeguarding the whole release and deployment process. The problem is that the point of microservices is to split, give independence, and benefit from that. But if you, somewhere along in the organization, you have a bottleneck in the form of a team of people that are actually quite often asked to ensure safety and stability, that ends up almost always in conflict. Because suddenly you have developers that invested in the architecture that allows you frequent changes. But what's the biggest enemy of stability and safety? That's changes. So I have ended up seeing teams just clash. Because, and if they didn't clash, the DevOps team would always be just overwhelmed. And if you really want to benefit from this kind of pattern in the architecture, ideally, you take the team apart, you put those people in the product teams, and you make them responsible for the same thing that other teams are. So, and now, if those people work as part of product teams, and on their quarterly reviews, they are actually judged by the fact if they enabled the team to ship fast, that's their goal. But if they are sitting in a different team ensuring stability, that's usually not their problem. Their problem is stability and not smooth, fast, and product delivery. So it's very important to make those people also responsible for fast product delivery. So if they're in the product team and you are releasing once every 3 months, it's their failure, and it's not the responsibility to make it slow. It's their responsibility to make it fast and safe. Another thing is testing. If you have monolith, it's easy to test because it's just one deployable. However, once you split into smaller parts, this becomes suddenly very problematic. So imagine if we go back to that image of Netflix architecture. Imagine trying to test the whole system end-to-end before each release. And you are talking some thousands of components that would need to be deployed, started up, synchronized, and tested. But you know what? If you are working in a proper microservice system where you try to benefit from independence, those components are constantly changing. You are quite likely to produce multiple versions per day. So imagine you wire up 2,000 microservices, you run your whole suite of tests against them, but guess what? During that time, 80 of them actually changed slightly. So what do? Do you repeat the whole process again? Do you synchronize and tell everyone to stop deploying while you are testing? No. Usually the solution is to try to abandon the idea that you can test everything at once and try to find some different way. So, for example, if you have some external services, if you integrate with PayPal, integrate with Amazon, you're probably not running your you are not treating those systems as part of your system. Those are external systems. And when you work with microservices, that's probably how you should think of other services. You know that there is a service out there. You know it's probably written in Java. You know probably people that are developing it. You know probably quite a lot of implementation details. But you shouldn't make those assumptions. There is an API out there that serves some functionality for you, and that's as far as you should assume. So at some point, you can't test everything. So you need to start thinking about either some stubs, contract tests, which results in stubs anyways, and learn how to live without full end-to-end acceptance tests, because that won't just scale at some point. You can pull it off with 5 services, with 60, probably with 100, but at some point there is some limit where it will become absolutely nightmarish. And the whole point is to enable the ability to make a change to a service and deploy it without changing anything else. If you can't make it, then probably that most of your benefits of the architecture, you won't just ever see them. You will just learn to live with the downsides of microservices and over-engineering. So that's where we arrive at another point, monorepos. There is always this discussion, what's better? Do we keep everything in a monorepo? Do we create a repo per service? And so on. And I've seen both work. However, there is one problem with monorepos. It makes it very easy to stick to the old habits. Because now, if you have independent services, forget about making changes to multiple of them at the same time. But if you have everything in a single repository, in a monorepo, it's very easy to make an atomic pull request that changes multiple services at once, which later on would force you probably to synchronize deployments of multiple services at once. That's working against what we've been fighting for when introducing microservices. So as much as you can have both work, I would say that if you go with a repository per service, you make it much easier for people to learn how to live with a distributed system. But if you have a monorepo, it requires a lot of discipline and a lot of extra tooling to make it work. You can make it work, but if you have a repo per service, probably every structured more or less the same. You can have it very easily discoverable by Jenkins, for example. But if you have one big monorepo, you need to invest probably quite a lot in the builds that can just subselect some modules, do a diff and build based on the content of the PR. That's a lot of extra work. So yes, it might be a bit more annoying to have a repository per service. But for example, in IntelliJ IDEA, you can actually put them all together under one project. So it will, at the end of the day, it will look like you are working with a monorepo while it actually being placed in independent repositories, not allowing you to make atomic commits. Another thing I'd like to bring up to you is not embracing eventual consistency. So you've built your 200 services. You are independent. You are deploying them independently. But now, look, they all communicate synchronously. So I'm not sure how many of those services can be on a critical path, but if probably one of those is down, your system stops working. And that kind of sucks, because you have 150 services, 2 of them are down because of some not very important reasons, and suddenly your whole system is down. And that's not the idea. When you invest in those services, if you really want to experience the benefit of that, you want to have this bulkhead behavior, which means that if one of the services goes down, some part of the functionality is degraded, but your system keeps working. Maybe you are, or perhaps it's not degraded. It works the same as it would in the past, but your eventual consistency is a bit more stretched. So your data doesn't end up consistent within a couple of milliseconds, but maybe in a minute or so. This is all the cost of giving your system a full high availability. So usually we can have two types of communication, synchronous and asynchronous. Synchronous means we just call the other service, and we get a result back. Asynchronous means it's another service publishing, and it's not just about wrapping your HTTP calls into an executor service and a future. It's more about changing the architectural style slightly. So you can imagine another service is emitting an event. Let's say user-created event. You are listening to it and building local projection of events that you have. So now you are the owner of the data. You can access data locally, and if the other service goes down, you still have some view, of the projection of the last user state you've seen. When the other service goes back up, it will start getting updated again. But at least you can quite a lot of users can actually do their work. I mean, you can because they are still available locally because your service is up and alive. However, if you have this style of communication, you trade consistency for availability because you no longer have a guarantee that your data is always up to date. And guess what? That's quite often okay. If you ask your managers, what do you want? Consistency, availability, or partition tolerance? They will tell you, obviously, consistency and availability all the time. But that's not how it works. At some point, at some scale, you need to make a trade-off. And usually the trade-off is consistency for availability. So if you can spot in your system those places where you don't really need to be 100% strict consistency all the time, that's where you can start getting some extra availability by loosening those guarantees. So, but if you really want to be truly independent in microservices, there's no way you can have strict consistency because it requires all the services to be up and responsive at the same time. So in sync communication, you call another service, but in async communication, you receive an event and build a local projection on top of that. And that requires some extra work, but the availability benefits are great. Obviously, make sure that you are applying this where it makes sense and don't default to that. Because in most cases, you probably want to default to synchronous communication and then go async in places where it's actually possible. However, there is one very important note. We need to distinguish between accidental consistency and eventual consistency. And this is pretty common. Eventual consistency does give us guarantees that our data will be up to date at some point in the future. It can be 1 millisecond, 10 seconds, 1 hour, 2 hours, days, a year. But at some point, we will catch up with the actual data. Accidental consistency means that what our system guarantees is that our system sometimes can be consistent, which is pretty much equal to no guarantees. And this is very, very common when teams especially when teams start introducing events into their systems. So imagine a scenario like this. We have a user service, it accepts a post at /users, and it saves users to a database, relational database, and then emits a user-created event, which ends up being propagated to the whole system via a message broker. It can be Kafka, RabbitMQ, whatever you want. And this is very, very problematic, because look at that part. What we want to achieve in this, if you want to have eventual consistency, we need to have atomicity at this level. If you want to have consistency, we want to have atomicity. So which means that we want the data to be saved in Postgres and in Kafka at the same time, or not at all. It will be a disaster if we have data that's saved only to Kafka or only to Postgres. Because then, if you have other services that embrace this async communication and local projections, if they never receive an event, that means it's no longer that their read models and local projections are permanently broken. And it's not fun to undo that. And making sure that actually behaves transactionally, it's way more complicated. But you'll be surprised, but this is quite a common scenario, that you just see those two, like two methods, persist and send, inside the transactional method. Don't get me wrong, I don't think people actually consciously use transactional to solve distributed transaction problems. But usually those systems start with a transactional method, which eventually gets an extra line that sends an event or does something else that needs to happen transactionally. So if you want to have strict consistency here, you probably need to introduce a third party and have some form of two-phase locking. However, this is pretty problematic because you require the third party, which is single point of failure, and there is way more pragmatic option to solve that issue. So the original issue is that we have a dual write to two systems, which are, well, don't support transactions. What can we do instead is that we can actually embrace eventual consistency. Because look, other services that are reading from Kafka, they are receiving those messages that are eventually consistent. They're not getting them immediately. So what can we do instead is we can move that second arrow to the database and pull data directly from the database to Kafka. So now you have a transactional write to your database, and then you can have some process that picks data up from the database and puts it in the Kafka. Guess what? From the end for the other service on the other end side of Kafka, that's still eventual consistency. So it's the same guarantees with a bit of extra work. How you can do that? Generally, what you are looking for is two types of two keywords. That would be transactional outbox pattern and change data capture in general. So change data capture is a general pattern which, as the name suggests, involves capturing changes made in a database. Transactional outbox pretty much involves building an outbox, another table which acts as an outbox in your database, which can be written to transactionally, and then have some form of CDC write from it into Kafka. So you can use Debezium for that, which is quite demanding to set up, but in the safest and cheapest way, you can have a separate thread that just reads from a database every couple of seconds and then realize those messages to Kafka. Well, if you have a couple of instances, you might end up generating a couple of the same messages. But guess what? That's a distributed system. And someone on the other end, anyway, needs to be prepared to handle repeated messages. Because exactly once is not the thing in distributed systems. You can have at most once or at least once. Another thing I'd like to talk to you about is a technology zoo. So one of the big benefits of our microservice architecture is that you can mix tech stacks now. So you don't need, if you've written your monolith in Java, you don't need to stick into Java. Now you have 100 services. You can mix Java with PHP, Golang, and Rust, right? Because the problem is that you can do that, but in most cases you don't want to do that unless you have a very good reason to do so. That sounds great on paper. All the technologies, PHP and Rust, holding hands and dancing together in our microservice architecture. But the thing is, in most systems I've seen, all the extra tech that was introduced generated problems, but didn't really give any benefits. Because suddenly there are, Rust CRUD microservices in your system, and someone needs to maintain them. So generally, let's say, as someone making strategical decisions in for architecture or for organization, I would say, don't throw in new tech unless there is a good reason for that. And most companies will benefit from standardized tech stack with occasional experiments. So let's say I'm not that big fan of a Spring Boot, but okay, that might be a standard in our company because, well, it has certain qualities that I care about. But we've heard about this experimental Quarkus, and we've heard it's pretty cool and new. So perhaps we default to Spring Boot everywhere, but then we make conscious decision to go for Quarkus. And that's a constant decision to deviate from the standard because we might want to try it out. We might want to build competencies for our teams, and so on, and so on. Well, at some point in time, it might turn out that our standardized tech stack, is pretty old, and no one wants to work with us anymore. People, when they heard about our stack, they just abandon the processes. well, then we can make another strategical decision to slowly evolve into another one. But standardized tech stack generally allowed to minimize problems. And the last thing for today is the dry abuse, a very noble effort. So that's a very simple idea, dry, don't repeat yourself. But this can backfire a lot if not understood properly. So what I've seen quite often is that people are a bit too abusive when it comes to dry, because they look everywhere in the code for repeating sequences of letters, and and suddenly they pull them out. Okay, that's the same. We pull it out. So this user domain class, and this user DTO, and that user that we save the database, they have the same fields. Let's merge them together and put those annotations together. So domain class has XML annotations, persistent annotations, JSON annotations, Lombok annotations, and so on. Guess what? But this user class, that's our domain class, that's also in the JPA entity and also a JSON, a JSON carrier for Spring Boot. Well, there are other services consuming it. So what? Do we repeat the same class in another service and to 5 other services that use the same user? No, let's create and that's how common library is born, common core and so on. So those reusable the same classes end up in a common module. Someone at some point figures out, okay, we have repeating dependencies in all the projects. We have Spring Boot. Some of those use RabbitMQ, some of those use Kafka, some of those use JPA, and so on. Let's put them all into a common module. And then there is some parts of repeating business logic in some place. Okay, let's put that in the common module. And this can contribute to dependency hell, which becomes incredibly tricky to debug when you work with Spring Boot, especially if you have a huge dependency graph. You change one bump small library, and suddenly it ripples through the whole dependency tree, destroying your Spring Auto configurations. But the biggest problem is that this introduces quite extensive coupling. So suddenly you want to make a change to your domain class that became a JSON contract class for another service. So you make a change, you need to release a new version of the library. But then you have 50 services that are using that library. So you need to bump it up immediately and release 50 services and so on. Or you say, which is usually something that leads to disaster, that we don't do that. That's a small change. It wouldn't break anything. Let's just release that one service that actually cares about the change. And we start accumulating changes. And at some point in time, one of those services actually needs to be upgraded. So we upgrade it plus 50 versions of this common module. We release it to production, and then something really weird happens. Sometimes your metrics disappear. Sometimes you go to production on H2 instead of Postgres. Happened to me. Jarek Ratajski knows, great story. You have to go to production without transactional annotations working, and so on. Fun stuff. Don't get me wrong. You can still have shared libraries and so on, but make sure those are libraries with narrow focus and treat it as libraries with their own release cycles and so on. And never put any business logic in there, because that never works. So usually there the question comes up. So I need to consume a REST API of another service. What do I do? Do I create my own DTOs? Would I repeat the same user classes all over again? The answer is yes. You want to make sure that you share a contract, you are coupled by a contract and not by Java classes, ideally. So and that thing you can do, for example, by making sure that your OpenAPI specification works. You can, if you have OpenAPI specification, you can actually auto-generate clients code right from that. But generally, that's the price of the independence. If you want to be independent, don't worry about writing a couple of lines of extra boring code for your DTOs. This gives you true independence, and as long as the contract is met, there are no problems. You don't need to worry about bumping up some common library and releasing. As long as contract is the same, you will be fine. But it costs a couple of lines of extra code. So that's pretty much how we arrive at the end of the presentation. Let me quickly summarize everything. So generally, don't start with microservices. Usually you won't, unless you know that you are starting up with a couple of thousand customers generating huge traffic. You want to start with monolith, or if you want to do some over-engineering, modular monolith, and start splitting only when you start feeling the pain, not before. So congrats, you've split your system into a couple of parts. Now you're working with n independent systems. Stop treating them like they are the one, because this will be way harder than maintaining a monolith, an evolving monolith. But if you start embracing the fact that those are independent systems, you'll get some of the benefits that I've told you about today. You are now prone to fallacies of distributed computing and network not being reliable. So that's not fun. And you need to think about that. So forget about strict consistency everywhere. Ensure eventual consistency, but not accidental consistency. And keep in mind that some messages can arrive more than once. And add the nuke tag only when there's really good reason to do it. Don't get me wrong, there can be a lot of good reasons for it, but just don't default to mixed tech stack by default. Thank you very much. If you want to find me on Twitter, here you are. You will find slides there, and you can. I don't think we have time for questions, so just catch me on the hallway track. Thank you.